Hello, Algebra 1 students. We're ready for Chapter 5. The first section in Chapter 5 is called Solving Inequalities by Addition and Subtraction. It's going to be a nice break from the types of problems we've been doing. The first page of your notes is a review of Chapter 4. So for the sake of time, I'm not going to be doing the review on our video. I'm going to jump right over to the second page and get right into our new vocabulary. This vocabulary really isn't new. It's a review from last year, but we'll start with set builder notation. We've already been using set builder notation. It's the accepted way to write a solution set. And remember, squiggly brackets are what we use to represent sets. And we use this mostly when we are talking about domain and range. Remember, domain is always your x, range is always your y. So if x is all real numbers, the set builder notation will look something like this. It's all real numbers, greater than 5. So we're doing an inequality this time. So we would say the domain then, since they gave us x, domain is x such that x is greater than 5. I got a little bit ahead of myself. It's not all real numbers, it's all real numbers greater than 5. So I have to say it's such that x, and here's our stipulation on x. X must be greater than 5. And then I close the set. Alright, and the words that are written, the shorthand here is x is greater than 5. X such that x is greater than 5. Alright, in our summary chart, this is our symbol for less than. Now realize that it's not equal to, so if we're graphing this on a number line, or even as we did our functions, the open circle means not equal to. This is the symbol for greater than. Again, it would be an open circle on the graph. This is less than or equal to. And because it says or equal, it would be a closed dot. I can't write and talk at the same time tonight. Less than or equal, so closed dot, greater than or equal, so another closed dot. Alright, the addition property of inequality says if any number is added to each side of a true inequality, the resulting inequality is true. So you started off in this example, A is greater than B. So if I add C to both sides, then A plus C is still going to be greater than B plus C because I'm adding the same amount. Same thing is true if A happened to have been less than B. If I'm adding the same amount to both sides, the inequality statement will stay true. I wanted to back up and come back up here. Students are all the time getting greater than and less than mixed up. And back when I learned greater than or less than, Pac-Man was a really big, popular video game. And I remember my teacher saying, the Pac-Man wants to eat the greater value. So this is the bigger number. He wants to eat the bigger number, and he wants to leave behind the smaller number. So if you don't like Pac-Man, you can think of it as an alligator. I'm not very good at drawing an alligator, something like that. There'd be his eyes, there'd be his nose, his teeth. The alligator wants to eat the bigger number. Alright, there's that. We solve an inequality very much like we solve an equation. So to solve for D, to isolate our D, we'll need to add 5 to both sides. So these examples are solving by addition. So D is less than or equal to 6. So on my graph, I come over to 6. Is it an open dot or a closed dot? It's going to be closed because it was equal to, and D is less than, so any number less than 6 is a solution to this inequality. If you wanted to check it, let's pick a number less than 6. Let's pick 3. Let's try 3. 3 minus 5, is that less than or equal to 1? Well, that's going to give me a -2. -2 is less than 1, so it does check out. All right, let's go back to the next problem where I'll add 12 to both sides. So C is greater than 77. Open circle. Oh, I don't have a, let's just pick 77. This would be 76. This would be 78, 79, 75. You don't have to put very many. 3 would have been fine. Open circle. C is greater than, so it's going to be going to the right. So you're going to draw your arrow to the right with an open circle because it was greater than and not equal to. For the sake of time, I'm not going to check each one of these. Here we have R minus a negative, which means plus 5. So to solve, we'll subtract 5 from both sides. R is greater than -7. So open circle on -7. R is greater than. A little hint to you, if you write the variable first, the inequality and the arrow are pointing the same direction. So R is greater than -7. Now they've thrown us a curved ball. We've got P on both sides of the equation. So I'm going to just go ahead and subtract 3P so that I can do this in as few steps as possible. -6 is greater than or equal to. Now I have all of my P's on one side, but be careful, the shortcut that I just gave you a hint about, I'm going to rewrite it with P first. P is not who Pac-Man wants to eat. Pac-Man wants to eat the -6. So you can rearrange the problem to use that helpful hint about the arrow is going to point the same direction as the inequality sign. So it's actually going to the left. P is less than or equal to -6. It's okay. I will absolutely accept this answer. I just rewrote it to help me, to aid me in graphing. As much as I would accept this part of the answer, if you graphed it, pointing it the other way, I would count that wrong. That is wrong. Writing the P last is not incorrect. Now, if I asked you, if I called on you in class and I said, give me the answer to number 4, please don't tell me that -6 is greater than or equal to P. You should say P is less than or equal to -6. All right, we're at a checkpoint. I'll let you work 5 and 6 on your own to check for understanding. By the way, when I look at your notes, if you've not attempted 5 and 6, you will not be given full credit for this homework assignment. I'm asking you to try these problems. They're very quick and easy. All right, key concept when we're talking about subtraction, the exact same thing as addition. If A is greater than B, if I subtract the same amount from both sides of the inequality, then the inequality stays true. So here we go. Let's subtract 23 from both sides. X is less than -7 because -23 is greater than, it's a greater absolute value, so you keep the sign of the bigger absolute value, which was 23, so it's -7. So X is less than -7. It's an open circle because it's not equal to, and your arrow is going to point to the left. Notice, because my green and my black, if I wrote right on top, you may not see it. So I just jump up a little bit, or you can make your line really thick, but I need to be able to see your pencil mark so I know which way your arrow is pointing, please. Even if you want to make it squiggly, you can make a squiggly. We'll do that next. All right. Well, I thought I was doing subtraction, but here I'm going to actually add 4 to both sides for this example problem. But I am going to subtract because we have opposite signs. So when you have opposite signs, you subtract and keep the sign of the larger. This should be a very nice review from pre-algebra. Now it's going to be a closed circle on -4 because of that equal to sign. M is greater than or equal to, so here's what I'm talking about. You could make your little lines go squiggly just so I can see your marking. All right, here's number 3. I have a variable on both sides. If I take 12n over, then I'll be done in one step. -4 less than or equal to 1n. But there again, you're going to want to make sure and think about n. The Pac-Man wants to eat the n, so n is greater than or equal to -4. So your arrow is going to the right. All right, subtract 4, x is less than or equal to -6. Rewrite that problem so that I can graph it correctly, although that is a fine answer. At -6, it's a closed dot because it's equal to, x is less than, so that means I want to go to the left because going to the left is where things get less. All right, we're at checkpoint 5 and 6. Do those two on your own. And let's look at the first word problem we should have time to do together. All right, Pena, she wants to buy 2 season passes. If her first season pass cost $54.99 and Pena only has $100 to spend on both passes, she wanted to buy 2, remember, the second season pass must cost no more than, there's the key words right there, no more than what amount? So it's an inequality. When it says no more than, that means we have a stipulation on how much money she can spend. So she only has $100. So whatever she's spending on the left needs to stay less than or equal to her $100 because it says she only has $100 to spend. And the first one that she really wants to buy is $54.99. So how much can the second one be? So $54.99 plus how much will stay less than or equal to 100? So now I have a simple one-step equation that I know how to solve. I'll subtract $54.99 from both. That's understood to have 0 change. So x is less than or equal to 45.01. So as Pena is looking to buy her second pass, if it's anything over $45.01, she will not have enough money to buy her second pass. Okay? I'm going to leave you the pancake problem to try on your own. So add that to your list of problems I'll be looking for tomorrow. That's a total of 5. And before I go, let me leave you with a really bad joke. What do you call someone who counts on their fingers? You may have heard this one before. They are a digital computer. Haha. That's really bad. Have a great day. Alright, just kidding. I only thought I was finished with this video. I need to back up. I just realized something. If you'll back up with me all the way back to the first page, we talked about set builder notation right here. Very first thing we talked about. Then as I solved the problem, sorry if that's making you dizzy, I failed to write this in set builder notation. The solution to number 1, it's D such that D is less than or equal to 6. I should have written that in set builder notation. So look here on the screen, I've gone back and I've written each of those in set builder notation. P such that P is less than or equal to -6. Same thing on the next page. It's a small technicality, but as you work these problems, it asks us to write the answer using set builder notation. So I want to be sure you know how to do that. Even on our word problems, I need to go and correct those also. So our solution for Pena, her money is X such that X is less than or equal to $45.01. That would be the solution set. All right, now have a nice day.